Good evening, friend. Set the day down beside you like a coat on the back of a chair, and let your breath find a slow, easy rhythm. The room is dim, the night is kind, and you are safe here. As your shoulders soften and the noise of the world drifts to the edges, we'll slip gently into a simple wonder, one you can listen to the way you'd watch snow fall. Tonight, we'll explore a quiet, astonishing question. What if our entire universe rests inside a black hole? No rush, no equations, just a calm walk through starlight thoughts, where gravity hushes the mind and curiosity glows like a nightlight. We'll trace the edges of an event horizon the way fingers trace the rim of a favorite mug, and we'll imagine how time might move differently in the deep, soft dark. If this peaceful space brings you comfort, tapping like and subscribe whenever it feels right helps other sleepy travelers find their way here. But for now, there's nothing you need to do. Let the body settle, let the thoughts float, and let the story carry you. When you're ready, we'll begin. Black holes begin as whispers in the fabric of space, places where gravity gathers so tightly that even light's swiftest of all travelers cannot slip away. Imagine them not as monsters, but as deep wells in a midnight field, the grass leaning in, the air holding its breath. Some physicists, listening to the mathematics the way sailors listen to the tide, wonder if the heart of such a well might not be an ending at all, but a doorway of what looks like collapse from one side could bloom as creation on the other. In that picture, a black hole is a cradle turned inside out, and somewhere beyond its inner hush, a newborn cosmos could be unfolding its first light. Before anything reaches the heart of that darkness, it meets a boundary that looks like nothing and feels like nothing, yet changes everything. The event horizon is not a wall, not a gate, not even a seam you could snag with a fingertip. For a very large black hole, drifting across it would feel as ordinary as moving through a shadow. No flare, no jolt, just the soft continuation of falling. The strangeness begins not in sensation, but in meaning. Once across, every path you can take bends inward, and no signal, no glimmer, no shout of particles can ever return to the open sky. From the outside, the event horizon behaves like the edge of no ability. Anything that crosses it becomes a secret the universe refuses to share. Light, matter, the delicate bookkeeping of history, the horizon keeps them all tucked away. Physics, which loves to balance its ledgers, insists that information is never truly lost. A burned log becomes ash and vapor, but the tally of its pieces still exists in scattered form. With black holes, that tidy rule seems to fray. The horizon swallows how and what alike, and to distant observers, the particulars blur into a single, simple story, a dark mass that grows heavier, a silhouette that tightens its grip. Time near this boundary behaves with a magician's calm precision. Watch from afar, and you would see a falling spaceship, slow as it approaches the edge, its signals stretching redder and fainter, as though dusk were pooling around it. To you, the ship never quite arrives. To those inside, clocks tick normally, breath rises and falls, and the horizon is crossed without ceremony. Two truths stand side by side, separated by perspective. One where the ship is forever pausing, one where it simply continues. The laws remain honest, yet the world divides into what can be seen and what can only be lived. This quiet schism reaches into the philosophy of science. If a boundary hides events forever, is reality the totality of what happens, or only what can be measured? The horizon suggests a universe stitched from partial views, space and time, cause and effect depend on where you stand and how you move. There may be no single master narrative that gathers every frame, only many partial films playing from different seats in the theater of the night. To mend the tension between information and disappearance, a daring idea glows at the horizon's rim, the holographic principle. Picture a lake at dusk, the surface holding a perfect image of trees and clouds. The proposal is not that the image replaces the world below, but that the surface could encode everything needed to recreate it. In a similar spirit, the event horizon might carry, in faint patterns and correlations, the full accounting of everything that has fallen in. 2 dimensions describing 3, a skin whispering the story of a hidden interior. If that is true, the horizon becomes not just a border, but a library, its pages written in the subtle script of quantum fields. No one has touched that boundary or watched it up close, yet the cosmos has offered glimpses of its outline. When a global web of radio telescopes focused on the giant in the heart of a distant galaxy, the data painted a dark circle ringed with firelight, an absence nested inside glow. That ring was not the horizon itself, but its shadow, the place where escaping light is scarcest, sculpted by gravity into a soft, storm-dark ring. A portrait made not of what is there, but of what cannot get out. Behind these images, the story of gravity unfolds from Einstein's insight. Mass and energy do not pull like magnets, they shape the stage. Space-time is a flexible loom. Matter weighs upon it and curves the threads. Near Earth, the weave is only gently bowed, which is why satellites must keep a careful count of seconds, or their maps will drift, and why starlight, passing the sun, bends by a hair's breadth. Near a black hole, the loom tightens and twists, and the lines of possible paths wrap into spirals and knots. There is a place outside the horizon where light can be persuaded to circle a precarious track called the photon sphere. Aim a beam exactly right, and it will run laps, balanced on a blade's edge of geometry. Nudge it inward, and it plunges. Tip it outward, and it escapes. The very existence of such a ring tells you how steep the curvature has become, how fiercely space itself is directing traffic around the dark. Cross the horizon, and the map grows stranger still. Inside, the roles of space and time begin to tilt. Moving forward in time becomes the same as moving toward the center. Every future you can choose leads inward, the way every stream in a valley eventually finds the lake. Trying to reverse course is as impossible as stepping into yesterday. The geometry doesn't threaten, it simply narrows, like a canyon whose walls lean until the sky is a ribbon. The inward path is not punishment, it is the shape of the terrain. In some solutions to the equations, those that let the black hole spin the fabric does more than curve, it drags. Space-time becomes like honey stirred with a spoon, swirling around the axis of rotation. Deep within that whirl, the math allows closed time-like curves, loops that trace a path through space-time and return to their start, as if a traveler could follow the river so faithfully that they rejoin their own wake. Whether such loops can exist in a world with quantum rules and noisy imperfections is still an open murmur of debate. Nature often permits possibilities in chalk that reality declines to host in stone. Yet their presence in the equations is a reminder. Give gravity enough intensity, and the usual grammar of before and after begins to loosen. Another curiosity arises when the equations are pushed to their edges. Instead of a single point of infinite compression, the interior might twist into a passage, the hint of a bridge that joins distant regions of space-time. A wormhole is that imagined bridge, a throat connecting here to elsewhere, perhaps even now to another now. On paper, objects could enter one mouth and appear from the other, skipping the long road in between. The catch is stability. Left to themselves, such tunnels pinch shut faster than any traveler could hope to pass. Keeping one open would require a strange form of matter with pressure that pushes outward more than gravity can pull inward, a substance that behaves like a negative weight in the arithmetic of space-time. Rotating or electrically charged black holes offer richer interiors in the mathematics than simple, non-spinning ones. In some sketches, the center does not end abruptly, but continues as a corridor, a bridge to another patch of the cosmic quilt. Whether that corridor exists in the world or only in the clean air of idealized solutions remains unknown. Quantum effects, like soft static layered over a symphony, may roughen and seal any such opening before it can be used. Still, the thought lingers like a moonlit path across water. Perhaps collapse is not only an end, but also a joining. These possibilities circle back to the early, tender question. If a black hole can hide a library on its skin, loop time in its depths, or cradle a tunnel in its heart, then perhaps its center can also seed a fresh expanse. In some visions, what we call a singularity is a throat where the equations of general relativity hand the story to quantum rules, and on the far side, expansion begins. The Big Bang of a new universe might look, from outside, like a black hole quietly growing heavier, while inside, space is rushing outward, smoothing, cooling, and writing its own galaxies into being. Our own sky, with its fossil light and web of clusters, could be the calm interior of someone else's collapsed star, the event horizon of that parent cosmos stretched into our boundary of everything. There is no demand here to choose a belief, only an invitation to rest with the shapes that science offers. The event horizon becomes an ink line where knowledge fades to gray. The photon sphere, a thin ring of circling light. The interior, a place where time leans and paths bend until inward and future rhyme. Even the paradox of information, stern as a ledger by day, softens at night into the image of a surface that remembers. If a black hole can be both a veil and an archive, both a fall and a beginning, then the universe wears a kind of gentle symmetry, like the tide that carries foam to shore and draws it back again. Lay these images down beside your breathing. Picture the horizon as a dark lake at midnight, perfectly still. Above it, a faint halo where light lingers. Beneath it, depths we cannot sound, where equations trace elegant arcs we may never sail. Somewhere in that quiet, a new space may be unfolding, as serene and inevitable as exhale following inhale. And if our own world is sheltered inside such a depth, then every star is a candle in a room within a room, and sleep is the simplest wormhole to close your eyes and you cross it, drifting without struggle into the soft interior of night. And in that interior hush, the darkness begins to turn slowly at first, then with a steady insistence, like a deep river swirling around a hidden stone. A spinning black hole takes the fabric of space in its arms and waltzes with it. This is frame dragging, the way rotation braids space-time and urges everything nearby to drift along, whether it wants to or not. Hovering becomes a kind of swimming against a current. East and west slide into curves. The old compass points soften like chalk in rain. Directions feel less like lines and more like eddies, and time itself leans with the flow as if the seconds have grown fins. Step inward, and the familiar grammar of space begins to slur. Distances refuse to stay put. What was straight arches? What seemed parallel converges like paths in a forest at night. Time, which outside the whole moves with the steady patience of tides, may loop into quiet circles in these equations, repeating like a lullaby that returns to its first bar. The stage does not collapse, it becomes elastic, wrinkling into folds and spirals, as though geometry has started to dream of other shapes. The event horizon remains the edge of what can be witnessed, not the edge of what can be written in mathematics. Past that unmarked line, the map allows surprising itineraries. A rotating heart, a Kerr black hole, twists space-time so tightly that certain routes might curl back toward their own starting moments. Physicists call these closed time-like curves, paths through the fabric where a traveler, if such a traveler could exist in such conditions, might follow the flow and meet the echo of their own past. Whether nature ever permits this beyond chalkboards and careful symbols is uncertain, yet the very possibility reminds us how plastic the world can become when gravity turns up the volume. Elsewhere inside, space might fold upon itself into bridges' slender throats that promise a shortcut between far-off rooms of the cosmos. These bridges have a name that sounds like a secret: wormholes. In the clean stillness of equations, an object could slip into one mouth and appear from another, skipping the long road between. But the throat is fragile. Left alone, it pinches shut faster than any hope can sprint. Only a most peculiar form of matter, with pressure that pushes outward against collapse, could keep it open. Exotic matter is the whispered term, a stand-in for physics we haven't yet invited into the room. Whether such support exists is a question with the hush of stars about it. All of this circling light, twisted space, time that loops like a ribbon in wind, flows out of Einstein's field equations when they are pressed to their extremes. Gravity is not merely a tug, it is choreography. The photon sphere, poised just outside the horizon, is a thin racetrack where light can run in circles, balanced on the keen edge between escape and surrender. Frame dragging is the gentle theft of direction by a spinning mass. And the horizon, quiet as a lake at midnight, is the place where all outward paths fold inward, not by decree, but by the shape of the ground itself. Black holes are not simply graves for matter. They are laboratories where space-time performs moves that the open, sunlit world rarely attempts. At the center of all these stories sits a word with a sharp point: singularity. The usual picture imagines a dot too small to see and too dense to imagine, a place where numbers run away to infinity and the music of physics becomes noise. But infinity in an equation is more often a warning light than a destination. It says, the road you're on has ended. The map you carry does not show the terrain ahead. In that sense, singularity may be less a thing and more a sign, our acknowledgement that the current rules have been stretched beyond their rightful reach. General relativity, the grand weaver of large-scale gravity, guides planets and sculpts galaxies, and it is exquisitely accurate where space is smooth and time is spacious. Quantum mechanics, the quicksilver logic of the very small, rules atoms and fields with a precision that is almost spooky in its perfection. But where space-time is crushed and curled to the limit, deep inside a black hole, both sets of rules try to speak at once. Their voices overlap. Relativity wants a smooth fabric. Quantum theory wants a granular hush. Without a single language to translate between them, calculations spit out infinities and leave us at a cliff's edge, staring into mist. A future theory of quantum gravity is the lantern many expect will steady our steps. In some proposals, Space-time is built from tiny loops, indivisible and countable, the way water becomes beads on a cool string when you look closely enough. Loop quantum gravity suggests that collapse stalls before the fabric can be torn. The loops push back, providing a pressure of geometry itself, so the fall may reach a minimum and rebound a small, dense bounce where infinite density never appears. In other visions, the world is woven from strings, minuscule and vibrating, whose harmonies write every particle and force. String theory adds hidden dimensions curled like sleeping ferns, and near the black hole's heart, these dimensions could awaken, changing the script so thoroughly that what looked like a breakdown is simply the entrance to new rules. Different paths, same whisper. The singularity may be a mirage born of incomplete knowledge. There's a useful echo in our own cosmic origin story. Run the expansion of the universe backward, and general relativity points not to a comfortable beginning, but to another singularity, the Big Bang, as an infinitely dense point. Most physicists suspect that early moment was no true point at all, but a fiercely hot, quantum-thick state where smooth space-time hadn't yet congealed. If the first page of our universe needed quantum grammar, perhaps the last pages inside a black hole do as well. The analogy doesn't solve the riddle. It simply reminds us that infinities have marked other corners of the map, where better theories later built bridges. What then becomes of the matter and light that fall? Do they dissolve into pure geometry, shrink forever, find another exit into another sky? Our instruments cannot follow them inside. We read the edges instead, the way a breeze tells you of a passing train you cannot see. We watch stars circle invisible anchors. We study X-ray flares from hot gas skimming a last orbit. We listen for tremors in the fabric itself when two black holes merge. Those waves ripple across the universe like rings spreading on a dark pond, carrying news from a realm where gravity roars. And with radio telescopes spread across Earth, we have glimpsed the shadow of a monster in another galaxy, a round void ringed with fire, the silhouette of space bent so tightly that light itself is held close. These are the footprints along the shore. The deep water remains unentered, but the pattern of the waves reveals the shape of what swims below. The philosophical hush grows deeper the closer we come to the alleged end of time. If, inside the equations, a path leads to a place where later ceases to exist, what becomes of cause and effect? Does a story with no last line still count as a story, or does time fold into some form our grammar can't express? Perhaps end is only the wrong word for a state where the coordinates we love no longer apply, the way north loses meaning at the pole. Physics is at its bravest when it admits these corners, when it stands on the snow line of language and breathes quietly, waiting for dawn. Meanwhile, the work continues with patient hands. Each new interferometer tuned to the sigh of space-time, each better image of a black hole shadow, each simulation spun up on a city of processors brings the horizon's outline into sharper relief. Theory tests itself against observation. Observation throws soft light back on theory. The loop closes and begins again, like waves on a midnight shore. Somewhere beyond our present page, the next grammar of gravity is taking shape, the one that will speak calmly where today our equations stutter. And while we wait, we can rest inside the images we do have. Imagine the rotating whole as a slow hurricane in the dark, its winds made of time and distance. Imagine light on its tight ring, circling like a lantern on a string. Picture space folding a discrete bridge and then thinking better of it, the throat closing with a sigh. See the supposed singularity not as a point that breaks the world, but as a veil behind which a different mathematics waits. None of these pictures demands belief. They offer a way to drift gently, steadily, through a landscape where gravity is also poetry, where the night holds both questions and their quiet promise of answers. Breathe with that promise. Feel the current of frame dragging like a slow tide guiding a boat. Let the idea of looping time become a distant lighthouse, not to be reached tonight, only to be seen. Let the word singularity soften into a placeholder, a ribbon tied around a mystery, so we don't lose it. The universe is not obliged to match our intuitions. It is obliged to be itself. And in the deep places where equations curve and soften, where horizons keep their counsel and light learns to circle, being itself is already a wonder. One you can fall asleep inside, the way a leaf settles on still water and becomes part of the lake. From afar, the darkness looks plain, only a silent circle where light forgets the way home. Yet, as stars share a name but not a life, black holes hide varieties within. The glow and storm we see outside are only weather. Behind that veil, the stories change, with weight, with birth, with the quiet habits of spin. Some are the compact ghosts of dying suns, stellar mass black holes, a handful to a few dozen solar weights. Their borders are only tens of miles across, and the gravity there steepens over the length of a body. A careless traveler would feel the feet pulled harder than the head, stretched like taffy into a thin, aching line. The fall becomes a narrowing corridor, and the tide of space does its work long before any meeting with the deep interior. Others are stately giants, supermassive black holes, millions to billions of suns gathered into one slow heart. Their horizons could cradle a planetary system. At that wide edge, the pull can be surprisingly gentle. One could drift through as easily as slipping from warm shallows into deeper water at night. Only far inside does the geometry tighten, and the choices of motion begin to thin into a single direction, inward. Size is not only scale, it is script. The largest holes may grant matter time to mingle, to stir and collide, to try out arrangements forbidden in smaller wells. Some models murmur that within these capacious interiors, unfamiliar physics may find room to show a new face processes that need pressure and duration only giants can afford. There are older seeds too, imagined from the universe's first restless moments, primordial black holes. Not graves of stars, but wrinkles in the baby cosmos, pinched by their own gravity before galaxies learned their names. Their masses could range from asteroids small to moon heavy. For the tiniest, quantum ripples dominate like waves in a teacup. Some may have long since evaporated through Hawking radiation, cooling by a whisper no ear could hear. Others, if they exist, might still drift through the dark, candidates for a fraction of the missing mass we call dark matter. Inside, the picture turns more like a quantum tapestry than a smooth cloth. Flickering fields, knotted energy, patterns with no daytime analog. Variety continues with motion and charge. The simplest, a Schwarzschild hole, neither spins nor holds electric charge. On paper, its interior funnels to a mathematical cliff where curvature rushes toward infinity. Real black holes almost certainly spin, drinking angular momentum from the matter that made and fed them. A Kerr hole twists space-time like honey around a spoon. In equations, the core is not a point but a ring, a loop where coordinates lose their footing. Idealized maps, Even sketch passages beyond the suggestion of elsewhere through the ring. But add matter, turbulence, and quantum jitters, and the clean corridor becomes weather. Inner horizons grow skittish. Tiny disturbances bloom. Predictions blur. The inside feels less like a tunnel and more like surf. Charged black holes, Reisner-Nordstrom in the ledger, introduce another curiosity. Their math allows two horizons with a strange middle country where time and space seem to trade jackets. Yet in the real universe, charge is a social thing. It gathers partners and neutralizes. Any large, lonely charge would be quickly cancelled by infalling opposite charges, and the elaborate inner layers on paper likely fade in practice. All this suggests a soft truth. Two black holes with the same mass may hide different hearts. Diet, spin, magnetic weather, the texture of the matter that falls each writes a private history into the interior. When two holes meet and merge something the cosmos has announced to us as gravitational waves, their shared spiral impact and ringing settle into a new, larger horizon. Those waves tell us about the dance outside, the way a bell's tone tells of its shape and strike. Whether any signature of the old interiors survives the union is an open hush. Some imagine tiny echoes or overtone patterns that, with future sensitivity, might betray differences within. Others suspect the crash scrambles every inward detail beyond retrieval. New detectors may yet hear subtler music and decide. Even now, black holes are patient laboratories where our two great languages, general relativity's smooth curves, and quantum theory's fine-grained probabilities, press against each other. Near them, time slackens, light can orbit, space folds, and knowledge draws a boundary in the shape of a shadow. Each black hole is both object and question, a dark instrument tuned to the limits of law. A further thought glows at the edge of this field. Add up the mass of everything we can observe: stars and gas, dust and planets, the hidden heft of dark matter. Ask what radius a sphere would need if all that mass were packed just enough to form a black hole. The result lands not in inches, but on the scale of the observable universe itself. Minds tilt. If the mass within our cosmic horizon sits inside its own notional Schwarzschild radius, could we already live in a geometry akin to a black hole's interior? It sounds like a trick until the distinction settles. Black holes are defined less by collapse than by the shape they imprint on space-time. Beyond a horizon, what we call space turns into a direction you must move the way tomorrow must arrive, an inward future. In our expanding universe, space grows in every direction, and the Big Bang stands as a horizon of origin. No signals from before can reach us. The rhyme is not perfect, yet it is clear. Both pictures speak of limits, of one-way arrows, of traded roles between space and time. Decades ago, Andrei Sakharov suggested that collapse might bounce under quantum rules, that what looks like a singular halt could be a turn. Later works sketched how the crush inside a black hole might seed an expanding region on the far side, a baby cosmos budding from the parent's interior. From outside, the black hole remains small and severe. From inside, a whole sky can unfold. Space rushing outward, smoothing, cooling, writing the first galaxies in faint script. In some solutions, a mathematical bridge joins the regions. In others, the link is a handing off of conditions where one set of rules yields to another. Either way, an ending is recast as a beginning. Follow the image further, and a branching forest appears. Each massive star's death writes a seed. Each seed could bloom into its own universe. Lee Smolin gave that vision a name that wears a biologist's coat: cosmological natural selection. Universes that are good at making stars become good at making black holes. Those that make many black holes beget more universes. The population shifts toward parameters that favor richness, long-lived stars. Patient chemistry, time enough for questions to awaken. It is speculative, yes, a theory humming just beyond the reach of handrails. But it holds a quiet symmetry. The rules that carve holes in one cosmos might be the rules that birth the next. Caution, like a lighthouse, keeps the shoreline clear. We have no balcony from which to view our universe set inside a larger room, no external observer to point at a horizon and name it. Similar equations do not guarantee identical worlds. A black hole in an external sky offers a surface you could, in principle, circumnavigate. Our universe grants no outside path. The parallels may signal kinship rather than identity. Black holes and universes as different verses of one geometry, not the same verse sung twice. Still, the elegance lingers. Black holes carry balances of temperature, energy, and entropy that feel naturally at home in cosmology. If our universe inherited its conditions from the interior of an older collapse, the just-so features that permit stars to burn, planets to cool, and minds to wonder may be less miraculous than generational. The thought does not demand belief. It only invites a softer gaze at thresholds, at how horizons can hide and reveal, how origins and endings can rhyme without touching. What would it mean in practice? Nothing changes in the warmth of a mug between your hands or in the creak of a floorboard before dawn. We are not crossing a cosmic surface on our way to morning. The idea is a way of reading, not a road to walk. A suggestion that black holes and universes might be two masks worn by the same deep logic, with sharper images of black hole shadows, with finer ears for gravitational waves, with a theory that lets quantum grain sit neatly on relativistic curve. We may one day know whether the kinship is family or resemblance. Until then, the images we already hold can settle beside your breath. Small black holes stretch like tight tides in a narrow inlet. Giants wear borders as soft as deep water. Primordial seeds drift like dark pollen. Spinning rings drag directions along, and charged solutions flicker on paper, then fade in practice. Mergers ring the cosmos like bronze struck once and left to sing. And the audacious thought remains that a horizon can be both veil and cradle. Let that thought lie quiet. The universe may be a grove of connected rooms, each behind a dark doorway, each lit within by its own scattering of stars. If so, every black hole is a closed eye with a dream behind it, and our sky is the bright interior of someone else's night. The room stays dim, and at the far edge of quiet there is always a soft threshold, a horizon that closes gently over what cannot yet be seen. Our own sky wears such an eyelid of distance. No matter how clear the night or how bold our instruments, there is a farthest reach our sight can travel before the light thins to nothing. Not because of fog or failure, but because the universe keeps stretching between us and the ancient photons on their way. That faint, invisible boundary is the cosmic horizon, a rim of time as much as space, where look back turns into never. On the other side, space goes on, galaxies go on, stars go on. Their light simply has too little history to reach us. It isn't only distance, it is the pace at which the fabric grows. Imagine walking toward a lantern across fresh ice while the lake glides outward under your feet. Step after step, the ice carries you back. However fast you move, the expansion can move faster still, and a limit appears quiet, implacable. This has the flavor of something we've met before, the event horizon of a black hole. That horizon is a one-way shore, cross from the outside, and every path bends inward, nothing returns. Stand far away, and you can never look past it. Our cosmic horizon is gentler, but sings a similar note. Beyond a certain reach, retreat outpaces arrival, and distant light can never close the gap. Space itself is the moving walkway, and the walkway is lengthening. Yet, likeness is not identity. A black hole's horizon is local, draped around a single object. Its shape answers to the hole's mass and spin. The cosmic horizon is woven into the universe as a whole and changes with time. When the cosmos was young and breathless, the horizon was near. As the eons passed, it drifted outward, letting more of the past come into view. Even now, some galaxies that we see as they once were will fade past our reach. Their future light will be tugged away by expansion until it can never arrive. Still, both horizons keep counsel. Each draws a line between what is knowable and what remains hidden. In the quantum murmur of reality, horizons are not empty silhouettes. They have a kind of temperature so faint it is almost a rumor. Black holes glow with Hawking radiation, a whisper of particles at the brink. A steadily expanding universe gives every observer a de Sitter horizon with its own ghost-cold warmth set by the rate of expansion. Even emptiness carries a thermal hush, as if the border itself were gently breathing. If a border can warm and tally, is it merely an accounting trick or something physical and real? The thought leans us toward another symmetry. In a universe with long-lasting expansion, each observer owns a personal horizon, shaped by where they are and how the fabric grows around them. These horizons block messages, store entropy, the measure of hidden information, and, in principle, radiate. We are not inside a black hole, yet we live with a horizon that behaves like one in miniature, not a wall of matter, but a limit written into geometry. Horizon stories are always about perspective. The traveler falling into a black hole feels no edge. The outside watcher swears there is one, and both descriptions speak faithfully for their seats. So too in the open universe, my horizon and yours do not quite match. Each of us carries a private border, stitched from our motion, our past, and our address in space. Reality does not lie. It simply hands each observer a different slice of its loaf. Physicists call this complementarity. No single witness can gather the whole tale, but the tales do not contradict. They dovetail like overlapping waves. Edge after edge, we start to suspect that information prefers the skin of things. In the 1,970 seconds, Jacob Bekenstein followed the clues and proposed that a black hole's capacity to hold information scales with the area of its horizon, not the volume inside. Stephen Hawking then showed that horizons are lively after all, that black holes slowly evaporate through a quantum shimmer at the rim. A puzzle bloomed at once. If the hole shrinks and the surface thins away, where does the information go? Quantum mechanics does not permit forgetting. Every note in the cosmic song must be accounted for. The search for an honest accounting nudged a radical notion into focus. Perhaps the interior is not the only place where the story lives. Perhaps the horizon skin encodes the whole tale like a shoreline whose ripples remember the stones thrown in. That image grew into what we now call the holographic principle. The idea that the full three-dimensional life of a region can be completely represented by information written on its two-dimensional boundary. Depth emerging from a surface, volume spoken by area. In 1997, Juan Maldacena crystallized this whisper into mathematics. Two very different theories, a gravity-bearing world in a higher dimensional bulk, and a gravity-free quantum field theory living on its lower dimensional edge, turned out to be perfect mirrors of each other. Every event in the bulk had a faithful retelling on the boundary. Physicists call this a correspondence, a precise duality. For our midnight purposes, the moral is enough. A universe with gravity can be fully described by a universe without gravity drawn on its boundary, like two languages telling the same story, line for line. Our own universe is not the special kind used in that exact duality. It expands and does not share the bulk's precise geometry. Even so, the correspondence proved that a holographic description is possible in principle. It suggested that space-time itself, the stage, the distance, the when and where, might be a kind of emergent story, arising from patterns of quantum information spread across a boundary we cannot touch. Clues point the same way from other corners. When we ask how much entropy the hidden bookkeeping of states can fit in any box of space, the ceiling scales with the area of the box's walls, not the volume of its interior. Again and again, nature tallies on the skin. It's as though the universe keeps writing reminders in the margins. Surfaces matter most. If all of this is a kind of grand hologram, what and where is the screen? Is it the far cosmic horizon, the rim of what we can in principle observe? Is it a boundary at infinity, a mathematical shore where light would arrive given endless time? Or is it something stranger still, a domain that is not in space at all, because space is what blossoms from it? The questions are lanterns. They light the path, even if they do not yet reveal the destination. None of this turns life into illusion. A hologram is not false. It is a different way of storing the same scene. The warmth of a cup, the hush of midnight air, the slow swing of a constellation, these stay as real as breath. The proposal is gentler and deeper. Maybe reality is fundamentally information, and geometry is how that information learns to sing. If so, a horizon is both a veil and a ledger, a boundary that hides and a page that remembers. So the comparison we began with settles into a quiet chord. A black hole's event horizon and the universe's cosmic horizon are not the same object, yet they share a family resemblance. Each limits what any one observer can know. Each can be assigned a temperature and an entropy. Each tempts us to think from the edge inward, to treat surfaces as primary and depths as stories they tell. Whether or not we live within a black hole's interior, we certainly live within a horizon's embrace. Let that embrace be comforting rather than confining. Beyond the border, more stars continue their patient burning. Within it, there is enough sky to last a lifetime of wonder. The cosmos may be a library that shelves its volumes on the walls, and we are readers by lamplight, turning pages that are also horizons. If the ultimate screen lies at the rim of what can be known, then the glow you feel now, the simple nearness of breath and heartbeat, belongs to the deepest layer any theory will ever reach. The layer where the universe and the listener are both present, quiet, and real. Edges invite beginnings, the way a shoreline invites the first step into water. Our own beginning is the Big Bang 13.8 billion years ago, a hot, bright rush where space, time, matter, and energy unfurled together like a banner in wind. Yet even a banner has a hidden hand that lifted it. What if that first flare was not the start of everything, but but a door swinging open from somewhere else. Some physicists give that door a gentle upside-down name: a white hole. A white hole is the mirror image of a black hole traced backward through time. Where a black hole keeps everything that crosses its border, a white hole admits nothing and sends everything outward. Picture a cosmic spring instead of a trap. No entry, only release. On paper, this falls straight from Einstein's equations. Reverse the arrow of time for a black hole solution, and you find its time-reversed twin. We have found no certain examples in the night. The sky is rich in wells and quiet about fountains, yet the mathematics is internally consistent, and consistency is often the lantern that lights new ground. Why tie such a spring to the earliest moment we know? Because the Big Bang already looks like an outpouring. If a white hole is the rebound of material once compressed beyond endurance, then a beginning that resembles an eruption may be the after of a prior collapse. Imagine matter and energy falling into a black hole in some older, larger cosmos, compressed to extreme yet finite density, and then, under quantum rules, pushed back. On the far side of that rebound, the inside would look like a new universe rushing outward. To its inhabitants, there would be no hint of an elsewhere. There would only be expansion, cooling, structure, and the long, slow writing of galaxies. Loop quantum gravity sketches one way such a rebound could occur. In that picture, space-time is woven from indivisible loops, a granular fabric that refuses to be squeezed to a true point. Collapse approaches a minimum size, then turns. The black hole interior does not end in a singularity, it pivots. The other face of that pivot, seen from within, would look like an ordinary Big Bang. Time inside would not be born from nothing. It would be inherited, passed through a narrow throat, the way a river passes a gorge and widens again downstream. This gives a softer answer to the riddle of before. If our Big Bang is the inside of a white hole like rebound, then the question becomes not what happened when time began, but what happened on the other side. The arrow continues even as the scenery changes, and it gives the matter that fell into a black hole somewhere to go. Rather than being erased, the story is continued. What went down emerges rewritten into a new sky. Creation and collapse become two halves of a cycle. Inhale and exhale across a cosmic chest. Caution keeps the thought honest. We have never watched a white hole switch on. The choreography required might be rare or forbidden in our patch of reality. Quantum rules may allow a bounce only at densities beyond any laboratory or star. And even then, the newborn region could seal itself off so completely that no message can pass between worlds. The laws allow the story. Nature chooses whether to stage it. Even so, a few clues keep a small light burning. Our universe is remarkably uniform. The microwave afterglow that bathes the sky is almost the same temperature in every direction, even across expanses that could never have shared news at ordinary speeds. Inflation and early, blisteringly fast expansion explains this beautifully. So would compression before a rebound. If what became our cosmos had once been packed tightly, it could have evened out its heat and smoothed its wrinkles before the outflow, then unfolded into a larger space already made calm. Another old rule murmurs nearby: cosmic censorship, the idea that true singularities keep their faces hidden behind horizons. Black holes obey, their cores are veiled. But the Big Bang seems naked, a visible singularity whose fingerprints we still read in ancient light. If our beginning is the white hole face of a singularity tucked safely in another universe, then the spirit of censorship is kept. The dangerous center remains hidden, while we see only the gentle side, the opening, not the wound. The notion also braids with the holographic view. If reality is, at heart, information written on a boundary, then the birth of a new region could be the rearrangement of that information, the boundary changing its script so thoroughly that a fresh interior appears. To a parent world, the death of a star writes a dense horizon on which data is stored. To the child world that blooms from that horizon's quantum pivot, the same data reads as initial conditions, a hot, expanding space with the right seeds for structure, like frost flowers forming on glass. Physicists have explored another path as well, white holes, not only as other-side births, but as late-life transformations of black holes within our own universe. As a black hole evaporates through Hawking radiation and dwindles, perhaps at the end of an almost unthinkable span it flips state, releasing its memory in a brief, bright sigh. In that scenario, the contents return to this universe, not to a separate one. It would not spawn a new cosmos, more a final unclenching than a delivery. But it shows that the equations do not forbid rebounds. They only require a patience beyond any human clock. Follow the thread, and a larger picture forms. If black holes can father white hole-like beginnings, and if those beginnings inflate into roomy, long-lived universes, then the cosmos might be a branching grove, parent worlds birthing children through collapse and rebound, children growing old and planting seeds of their own. We would inhabit one room of a mansion without end, the hallway behind us forever closed, the rooms ahead invisible, all connected by doors that only ever open from the far side. In such a mansion, the Big Bang would be less a shout from nothing and more a whisper passed from one room to another. None of this is settled. We have equations that draw plausible maps and observations that set boundaries. Those maps must respect. We listen to gravitational waves from distant mergers. We sketch the shadows of giants at galactic hearts. We match simulations to the faint static of the early sky. Each clue trims the wildest branches while leaving the sturdy trunk of curiosity intact. Whether our Big Bang was a local dawn or a doorway, the night remains generous with possibilities. Let the idea rest beside your breathing. A white hole is a fountain where a black hole is a well. A rebound where collapse seems final. A start that is also a continuation. If our first light rose from such a fountain, then time is older than our sky, and the matter of our bodies once passed through a narrowing we cannot picture. If not, the thought still teaches us how to see beginnings without demanding absolute origins, how to let cycles and bounces share the stage with singular sparks. Either way, the story is tender. Black holes are not only endings, they might be wombs. The Big Bang need not be a solitary shout. It can be an echo in a larger conversation. And somewhere in that conversation, very far from here and yet strangely near, another horizon could be brightening, another interior opening its eyes quietly, inevitably, as gently as breath moving in a sleeping room. Breath settles. The cosmos keeps pace, a long inhale that widens the dark, a softer exhale that may one day return it. Our universe is mid-breath now, expanding, lantern galaxies drifting apart on the black river of space. Yet the rules that cradle stars never promised widening forever. In some stories, gravity gathers its patience and the fabric begins to draw in. Galaxies creep closer, stars dim, matter clumps, distances shorten. The great unfolding slows into a long descent, a big crunch that mirrors the Big Bang, the way a closing hand mirrors an opening one. Follow that descent, and familiar grammar blurs. Heat climbs, densities soar, and equations that served in open spaces falter in the crush. The end begins to resemble a beginning, a compression kin to the heart of a black hole. As a massive star becomes a dark well, a whole universe might end by becoming a seed. Some maps place this within a larger room, higher dimensions cradling our space like air around a bubble. From the outside, a collapsing universe would resemble a black hole forming, its surface tightening into a horizon. From the inside, the view could be entirely different. A sudden opening, a rush of room where none had been, a fresh expansion that feels like first light. Birth and death, from different balconies, can be the same event. Cosmological natural selection imagines every black hole as a seed that sprouts into a new universe, with its physics nudged by a hair gravity, a touch stronger or weaker, particle masses retuned, balances slightly shifted. Universes good at making stars are good at making black holes. Those rich in black holes leave many offspring. Over eons, the family drifts toward parameters that favor richness, long-lived stars, heavy elements, patient chemistry. Our cosmos may be fertile simply because fertility survives. Loop quantum cosmology offers another path to renewal. In that story, space-time is granular, woven from tiny loops that refuse to be crushed to a point. Collapse slows against that granularity, reaches a smallest, densest state, then rebounds. The end of one universe becomes the beginning of another. Carry the thought into black holes, and each horizon turns into a hidden nursery beyond the veil. A new region with its own clock and distances begins to spread. From within, it feels like a first morning. From above, like a leaf bud on a tree, too vast for any single gaze. Thread these ideas, and a quiet orchard appears, a multiverse grown from fall and bloom. We cannot say where such growth lives, only that the mathematics keeps a door ajar. Collapse as sowing, horizons as membranes, new spaces budding from old wood. There is a nearer thread. Suppose, just as a working picture, that our universe truly is the interior of a vast black hole. What would we notice from inside? Edges would be impossible to find. The boundary would lie forever out of reach. Light and matter guided inward by the shape of space. To us, the world would look endless, like a forest to a traveler who never finds the rim. Looking outward, galaxies redden and fade, their light stretched by expansion until it slips below our instruments. Perhaps that cosmic redshift whispers about deep curvature just beyond our sightline. Mathematics is where resemblance earns patience. The equations that guide our expanding space, the way distances grow, the way clocks disagree depending on their path, share structure with the equations for regions inside rotating black holes. In both tales, space is not fixed, and time is not uniform. The fabric itself speaks. Kinship is not proof, but it invites the thought that our cosmos reflects boundary conditions set by a larger frame. Geometry offers another hint. If the cosmos is closed, curving back on itself like the surface of a sphere, then it is finite, a bounded volume one could circle without ever finding a wall. Such a shape suits the idea of an interior, bounded by a horizon. From within, the world would seem edgeless. From a higher dimensional vantage, our space would be wrapped and contained. Measurements suggest near flatness on large scales, yet near leaves room for a whisper of curve. Information leaves a trail. In black holes, the bookkeeping of possible states scales with area, not volume. The horizon's surface counts more than the depth. If our universe follows a similar rule, reality may be holographic, a deeper description, living on a boundary we cannot touch, with everything inside emerging from its encoded script. Such a view neatly folds puzzles why information is not lost, why entropy ceilings care about surfaces, why gravity and quantum theory might be two languages for the same play. The oldest page we can read is the cosmic microwave background, the faint afterglow of youth itself. It is astonishingly smooth, but not perfectly so. Tiny ripples, slight alignments, soft asymmetries remain. If our cosmos came from a rotating, turbulent collapse, some of that motion could be imprinted in these patterns. A preferred axis here, an unexpected correlation there, nothing loud. Only hints that the first conditions were spun before they were smoothed. Surveys keep any global rotation very small. Limits tell us how quiet any inherited swirl must be. Dark energy writes another quiet line. It pushes space apart with a patient hand, giving expansion a steady, accelerating tug. Its nature is still obscure. If we live in a region shaped by extreme curvature, perhaps this speeding up is not a new substance at all, but a boundary effect, the geometry's own habit asserting itself. In that picture, acceleration is not an extra ingredient, but the way confined space relaxes. Even the scaffold beneath time and distance might carry clues. If space-time is pixelated at a scale beyond our reach, there is an information budget no more states than there are cells. Black holes already respect such budgets strictly. If quantum gravity extends the rule everywhere, high-energy phenomena could betray the grain. Slight dispersions in the flight of the fastest cosmic rays, tiny deviations from smoothness at the highest energies, cutoffs that hint at hidden conditions. Some signatures make sense if our universe is curled within a higher structure, its edges untouchable yet influential. We cannot stroll to the border and look back. We cannot send a probe to circle the horizon and return with photographs. Our method is subtler. Map patterns, compare stories, stretched light, galaxy flows, ripples in space-time, the hush of microwave glow, and ask if one explanation lets them sit together without quarrel. If a consistent picture places us in an interior shaped like a black hole's, the frame of the painting changes even if the colors remain. None of this makes the world less real, only more intricate. The night that looks boundless could be cradled. The distances that seem infinite could be contained. The rules we measure could be heirlooms from a parent space we will never see. Humbling, yes, and strangely kind. Everything we are, every photon caught, every breath drawn, every thought laid gently to rest, belongs to a larger cycle that wastes nothing. Collapse feeds creation, horizons hide and preserve, information migrates, changes costume, and goes on. So let the images drift beside your breath. Galaxies recede like quiet embers within a globe of unseen glass. The glass is a horizon that keeps its secrets and still tells its tale on the skin. Space-time may be granular underneath, counting its own possibilities. Above our knowing, apparent geometry may hold this chamber in its palm. Whether or not the universe is literally the inside of a colossal black hole, the kinship is steady. Horizons with temperature, areas that count more than volumes, beginnings that look like endings turned around. Somewhere in the quiet between stars, a gentler riddle keeps tugging at the hem of thought. What becomes of memory when a black hole grows old and thins to ashlight? Not the grand swallowing, but the vanishing bit by bit, a long drizzle of faint radiation. To listen for an answer, physicists have leaned close to quantum tools, to entanglement's secret handshakes, where particles behave like partners who finish each other's sentences from opposite sides of the room. A simple sketch tells the tale, the page curve. Picture a line that tracks how much information seems trapped inside a black hole as it evaporates. At first, the line falls. Whatever falls in appears lost, and the radiation leaking out looks like static. No message, no meaning, just warm noise. Time passes, then the line turns. The trickle of light begins to carry structure. Patterns creep in. The later radiation is laced with clues about what once slipped past the horizon. By the end, if you had the patience of eons and the perfect key, the outflow could, in principle, contain the whole story, scrambled but intact. The universe keeps its ledger. Nothing is deleted, only disguised. This picture makes black holes feel less like trash fires and more like impossible safes, quantum devices that shuffle and mask information so thoroughly that recovery is beyond ordinary reach. To test the idea, without drowning in math, theorists build toy worlds where the rules are simpler but honest. In these small laboratories of symbols, the page curve appears, entanglement stitches inside and outside together, so that bits of knowledge seep into the glow with a timing that makes sense. Not proof, but reassuring echoes. And yet a sharper proposal, cut through the calm like frost across glass, the firewall. It begins with a quiet principle of Einstein's, the equivalence principle, the promise that free fall is locally indistinguishable from floating. Drift through the horizon of a huge black hole, and nothing special should happen. No jolt, no flame. Only the same soft physics you'd feel in a dark, empty elevator. The true ferocity waits deeper in. The firewall refuses this gentleness. It says the horizon itself is a sheet of searing energy, a place where anything that touches is undone in an instant. Why such drama? Because quantum entanglement has a rule nicknamed monogamy. One perfect secret cannot be perfectly shared with two partners at once. If late-time Hawking radiation is entangled with early-time radiation in order to carry information away, it cannot also be fully entangled with whatever remains inside. Something has to yield. In 2012, a quartet of physicists pressed the logic and found that keeping quantum rules strict might shatter the calm horizon. The argument didn't claim distant observers would see flames. The burn would be for the falling traveler alone. Even so, it shook a pillar. If true, the smoothness promised by relativity fails at the edge of the most mysterious objects we know. Many were unconvinced. A wall of fire at the boundary felt like a cure that harms the patient. Perhaps our understanding of entanglement near gravity needs new language. Perhaps information slips out through subtler channels than we have yet imagined. Others whispered a different unifying line. What if space-time itself is not fundamental, but woven from entanglement threads of correlation, knitting geometry, the way harmonies knit a song? If so, a paradox that treats space and entanglement as separate might be asking the wrong question. That line of thought bends toward a compact slogan with long roots. ER equals EPR. ER for Einstein-Rosen, the old wormhole solutions. EPR for Einstein-Podolsky-Rosen, the old entanglement puzzle. Put together, the hint is that entangled systems may be connected by microscopic bridges. No highways, no travel for people, just quiet links in the geometry that mirror the quantum ties in the algebra. In this view, the interior of a black hole could remain in soft conversation with the radiation outside, not by brute leakage, not by tearing the horizon, but via these hidden threads. Information escapes as correlations mapped through tiny tunnels. The horizon stays kind, the page curve is honored. The universe keeps both of its great promises at once. Between fire and thread stands the real question. Which principles are bedrock and which are scaffolding? If the firewall is right, the equivalence principle fails at the sharpest edge of gravity, and smooth space-time is only an approximation with a burn mark where the black begins. If ER equals EPR, and its relatives are closer to the truth, then geometry and entanglement are two faces of one fabric. And no flame is needed, only a deeper pairing between gravity and quantum rules than we have yet learned to speak. Either way, black holes force clarity. They do not settle for half answers. They ask whether reality is continuous or grainy, whether causality hums without crackle, whether memory can ever be truly lost, whether inside and outside are absolute or braided. They turn our best theorems into questions and leave them on the nightstand, next to the cooling cup and the slow clock. Listen to the shape of the possibilities without bracing. In one, horizons are gentle, and information returns as late music, encoded in delicate variations of the radiation's long fade. In another, the edge itself is different than it looks, a place where quantum loyalty to one partner overrules the calm of freefall. In a third, the very distinction between edge and link dissolves, because the map of space-time is stitched from entanglement. To begin with, rip a stitch and geometry phrase, add a stitch and a bridge appears. Each path changes how we imagine the night. If the page curve is a universal law, then the cosmos is a faithful archivist. If firewalls stand, then some rooms are not meant to be crossed. If ER equals EPR sings true, then every entangled pair, from the tiniest qubits to the broadest fields, is also a hint of hidden passageways that only information can use. You don't need the equations to feel the balance. Think of a music box that plays a tune only after turning in silence for a very long time. Think of a lock whose key is made of patterns rather than metal. Think of a tapestry where pulling one thread rearranges the entire picture at once. These are only images, soft lamps to light a very strange corridor, but they help the mind stroll without hurrying. What matters here, in the near sleep dark, is the kindness of the pursuit. People build toy worlds out of symbols and test them until they sing the right melody. They listen to gravitational waves for harmonics that might betray hidden structure. They analyze the faintest hiss of ancient light for hints of a twist. They argue, because arguments are how truth becomes less shy. And all of it is in service of a question so small it fits under a pillow. Does the universe ever forget? Whatever the verdict, flame, thread, or some gentler mechanism we haven't named, black holes are not mute prisons. They're classrooms where gravity and quantum law meet after hours and compare notes. Their silence is the kind that invites attention. Their darkness is the kind that makes faint patterns easier to see. Lie back with that thought. The horizon does not need to harm you to tell the truth. The truth does not need to shout to be heard. Somewhere, a curve that measures memory is bending upward. Somewhere, a bridge no wider than a secret is holding two halves of a story together. Somewhere, a paradox is loosening like a knot under practiced fingers. Far beyond the last streetlight of our thoughts, there are regions where gravity hums so deeply that even light bows its head and does not return. Around such regions, black holes, the border is a soft, invisible rim called the event horizon. Cross it, and every future path tilts inward. For a long time, we imagined these objects as perfect vaults, quiet, sealed, eternal. Then a faint whisper entered the story: Hawking radiation, a slow, ghost-like glow that seeps from the edge and tells us even the darkest wells are not forever. The picture begins with the restlessness of so-called empty space. Quantum rules say the vacuum is never still. Pairs of particles flicker into being and fade before they can be noticed. Near a horizon, the tide is uneven. One partner can be pulled down, the other pushed out. The one that escapes becomes real, and the black hole pays the bill by surrendering a pinprick of its energy. One breath, then another, over unimaginable spans, and the mass dwindles. For stellar mass holes, the fading is slower than the age of the universe. For giants, slower still. To us, they look timeless. But time is patient, and the ledger keeps adding tiny subtractions. When Stephen Hawking first traced this glow in the 1,970 seconds, he treated it as pure heat, featureless, like the warmth from a brick left in sun. If that were the whole truth, the tale of whatever fell inside would be erased. Toss a library into a furnace, the fire will blaze, but the stories are gone. Physics, however, shelters a stubborn promise. Information is not destroyed. It can change costume, scatter, and hide, but it does not cease to be. That promise turned Hawking's lovely calculation into a paradox that would not sleep. A gentler answer took shape years later, in a curve drawn in quiet ink. Don Page showed how the entropy of the radiation, the measure of how much hidden information it might carry, should evolve if the universe keeps its promise. Early on, the emission looks random. Then, after a long wait, the curve bends, structure creeps in, late radiation begins to encode what fell. By the time the black hole is done, the ledger balances. Nothing is lost. Everything is scrambled. Imagine a melody poured into a hall with strange acoustics. At first, it is only echo, but slowly, notes reassemble. The whisper is faint beyond imagining, and the horizon is not the perfect sphere we once drew on chalkboards. It can ripple and wobble, a taut drum skin stirred by infalling matter and by space-time's own tension. Black holes, it turns out, are instruments. They hum not only in light, but in the fabric of distance itself. That second music, gravitational waves, was heard for the first time in 2015. For centuries we studied the sky with light, visible twinkle, radio hush, X-ray flares. But light has its shy spots. It scatters, it's blocked, and black holes swallow it whole. Gravitational waves, by contrast, pass through dust and silence without complaint. When two black holes spiral together, they send out ripples that carry the shape of their dance, a clean imprint of mass, spin, and motion, straight to any ear, delicate enough to listen. The choreography comes in three movements. First, a long, tightening spiral, two dark bodies circling closer, lap by patient lap. Then the merger, a swift joining, all momentum and heat of geometry, no light at all. Finally, ring down. The newborn whole quivers and settles, like a bell after the strike. This last tone is made of quasi-normal modes, the natural notes of the object shape. Measure them, and you can weigh the new black hole, find its spin, check the curve of space-time around it, all from a few seconds of faint tremor. The possibility that quickens the pulse is subtler. If the interior of every black hole were the same, a pure funnel to a singular point, then holes with the same mass and spin would ring indistinguishably. But if something more intricate resides within, if horizons keep memories in delicate ways, then the tones might carry tiny fingerprints. One day, With quieter detectors and longer listening, we might hear differences no eye can see and sort black holes not just by size and spin, but by the whispers of their hidden architecture. How could the inside talk to the outside when nothing escapes the horizon? The clue returns us to surfaces. Counting the possible states of a black hole, its hidden microstructure reveals a surprise. The count scales with the area of the horizon, not the volume within. It is as if the skin records everything that crosses it. This is the spirit of holography, the notion that the full three-dimensional life inside can be encoded on a two-dimensional boundary. In that light, Hawking radiation, the tug on nearby stars, even the fine texture of a ringdown are shaped by a ledger written on the surface. The inside is not shouting through the wall already holds the story. For years, we repeated a tidy slogan, "Black holes have no hair," meaning only mass, spin, and charge define them. The rest of the past is shaved away. Newer ideas suggest a softer revision. Perhaps there is soft hair, traces too subtle for early instruments, but real enough to matter. Patterns in the radiation, tiny phase shifts in the waves, faint asymmetries in how horizons tremble. Not locks flowing in vacuum, but quiet signatures that let history cling. Learning to read these marks is like learning to read the wind on water. We practice on simplified worlds, mathematical models, where the rules are clean yet faithful, and look for the page curve to rise where it should. We map the wiggles in the ancient microwave afterglow for hints of unexpected alignments. We ask ringdowns to confirm that gravity's notes agree with relativity's sheet music. Each success narrows the range of what the interior can be. Each surprise invites a kinder theory. None of this turns black holes into gentle creatures. Their gravity is relentless. Their edges are one way. But within that sternness, they participate in something almost generous. They preserve the past, albeit in code. They ring with the facts of their making. They heat, barely, in a way that lets the universe keep its books. And they invite us to marry two languages, quantum information and curved space-time, until they speak as one. Imagine then, a night where a distant galaxy hosts two invisible dancers. As they approach, space-time around them sings in a frequency too soft for human ears, but not for our new instruments. The song rises and blends. There is a last slick turn and a single body takes the floor. A fading chord follows quasi-normal, beautiful for its lack of ornament. Hidden in that chord are the simple numbers we expect and, perhaps, one day, a sliver of biography. At the border itself, virtual pairs continue their tiny lotteries. Sometimes, one partner wins freedom, and the black hole pays in mass. Ages pass, the ledger balances. The vault proves less like a shredder and more like a patient archivist that works in strange script. If we learn to translate, the rewards will be quiet yet vast. Hawking radiation will become less rumor and more text. Ringdowns will sketch interiors we cannot visit. The hair will stop being metaphor and start being measurement. We will see whether the old slogan truly needs trimming, whether holography is a metaphor or a map, whether information rides out on subtle correlations like seeds on wind. For now, let the image settle without strain. Black holes are not merely endings, nor merely mouths that devour. They are instruments tuned by gravity to play the universe's deepest notes. They are mirrors that blur but do not lie. They are places where our two best ways of knowing quantum and geometric meet and bow to one another. As you drift, Think of that bell tone fading across billions of light years, untouched by dust, as faithful in its arrival as a heartbeat returning after a held breath. Think of the faint warmth at a horizon, adding up over eons to a farewell. Think of a surface that keeps the story of everything it has met, written in a language we are just beginning to sound out. And let that be enough for tonight. The knowledge that even the darkest places keep their promises, that memory scatters but endures, and that somewhere in the quiet, the cosmos is playing a long, soft note we have only just learned to hear. Our new ears are still young. Since we first caught the faint shiver of space-time, the catalog has grown dozens of black hole collisions stitched into the archive, each a quick flare in the otherwise steady dark. The notes arrive brief and hushed, ring-downs flickering for a heartbeat before slipping into silence, their long journeys sanding them down to whispers by the time they reach Earth. We can weigh and time them, but the fine grain we crave lies at the edge of hearing. Sensitivity is sharpening. The ground-based instruments that opened this sense, LIGO and Virgo, are the first lanterns, not the skyline. Plans already trace bolder arcs, a buried triangle in Europe called the Einstein telescope, built to damp the Earth's restlessness and listen deeper and far from any tremor. A constellation in solar orbit, LISA, 3 spacecraft, flying in a triangle millions of kilometers across, reading distances with light. Where our current detectors catch the quick, high chirps of stellar mass mergers, LISA will lean into the low, slow voices of giants at galactic centers. Those songs may linger for hours or days, long enough for us to follow the overtones and feel the texture of the instrument that plays them. Texture is where shy physics loves to live. If quantum effects ever leave their fingerprints on gravity's music, they will hide in the fine structure of those tones, tiny shifts in pitch, faint beats between close frequencies, the way the tail of the ring-down fades. Competing theories of gravity hum slightly different scales. With a quieter room and longer notes, we can hold the tones side by side and see which score the universe prefers. Some of the boldest sketches imagine that the horizon itself is not exactly what Einstein's equations suggest. Perhaps, just outside the would-be point of no return, there is structure, a tangle of fundamental strings, a hazy fuzzball, or some other exotic skin that remembers. If so, the ring-down might not simply melt into quiet. It could echo, not echoes you could hear with air, but repeats in the gravitational wave, fainter copies of the original chord, delayed by tiny reflections from the near-horizon structure, like a voice returning from a canyon with soft insistence. Teams have looked for such patterns in the data. The results so far are tentative and contested. A handful of suggestive bumps and many cautions about noise. Even uncertainty carries energy here. It tells us exactly how sensitive we must become to turn rumors into readings. Because if echoes are real, then the border of a black hole is more than a clean line in geometry. It is a complicated place where quantum texture and gravity's curve shake hands. Even without exotic add-ons, the waveforms themselves are astonishingly informative. A merger changes the gravitational field in a way that ripples outward. Those ripples encode the whole event's posture, how the masses pulled, twisted, and fused. The process is like watching a drumhead in motion. You cannot see the hollow, but the pattern of vibration tells you about tension, depth, and whether anything loose rattles inside. With better instruments, delays and dispersions along the wave's path, microscopic timing differences can reveal how space-time is warped near the horizon. Tiny phase shifts become clues. Slight asymmetries become hints. The whole signal becomes a map made of rhythm. If we can collect enough of these songs, a catalog will bloom black hole voices arranged by mass and spin, but also by subtler timbre. Just as human voices carry the marks of life, age, health, joy, grief, these cosmic voices may carry signs of an interior we cannot enter. Over time, we might learn to hear the family resemblances and the private histories. One path of speculation threads through a deeper tunnel. We once treated black holes as mere endings. Now we ask whether some could be passages. The image is simple: space as a sheet you can fold. Two faraway dots drawn on it can be brought together, and a short tunnel punched between them, the basic picture of a wormhole. The mathematics has both generosity and caution. The first solutions pinch shut too fast to traverse. Later work finds a loophole. If a throat can be held open with a strange, outward-pushing energy, negative in the accounting of general relativity, the tunnel might persist. Not the stuff of daily life, but not forbidden by quantum rules either. From far away, a wormhole could wear a black hole's mask. Both bend light into rings. Both cast similar shadows in glowing gas. Both police an apparent horizon. The difference lives inside. A fall into a black hole ends in crushing. A fall through a traversable wormhole would deliver you elsewhere, another region of our galaxy, another galaxy entirely, or in the bolder drafts, a different universe with its own script for physics. How to tell the masks apart if we cannot peek beneath them? Only by listening closely for mismatches. A wormhole could produce odd timing in jets, flashes that arrive out of step, gravitational tugs from something you cannot see on this side, or yes, its own pattern of echoes, waves rebounding within the throat before leaking out. These would be delicate signatures buried under ordinary noise, but not beyond the reach of careful persistence. The idea binds naturally to the quantum world's most tender strangeness: entanglement. Two particles can be linked so completely that a change in one is mirrored in the other, across gaps that would make a signal blush. Some researchers whisper a compact equivalence: entanglement as tiny bridges, wormholes as the geometric face of quantum connection. If this poetry holds even partly true, then passage is less about travel than about correlation. Woven into space-time, a network of microscopic tunnels no ship could sail, but through which information can be faithfully paired. The boundary between inside and outside softens. The horizon becomes a place where relationships are stored. None of this demands that we abandon caution. A genuine traversable wormhole big enough for travelers may never occur in nature. If it does, it may be wildly unstable or lethally radiant. Even a microscopic one would be a landmark, and we would meet it first as a pattern, not a doorway as a deviation in a spectrum, a timing offset, a signature in polarization. We will likely prove or rule out the most dramatic versions long before we argue about engineering. In parallel, the practical work is beautifully grounded. Detectors must be quieter, mirrors steadier, lasers cleaner, seismic murmurs need calming, quantum noise needs shaping. Data pipelines must learn to sift whispers from wind. Spacecraft have to fly in formation across millions of kilometers with a poise that borders on ballet. Each technical victory buys a little more of the universe's confidence. There is a softer reward as well. The way this listening knits together our best ideas. Gravitational waves test relativity. with every crest and trough. Their late-time structure teases quantum hints at the border of strong gravity. The possibility of echoes asks questions no telescope can. Is the horizon truly smooth, or does it carry memory? Wormhole lookalikes invite us to reconcile geometry with information, to ask whether the most practical definition of where is not a coordinate, but a pattern of entanglement. Hold the images without strain. Somewhere, a pair of supermassive black holes is circling in a slow waltz that will last years, and a listener like Lisa will one day trace their steps note by patient note. Somewhere else, a smaller pair is finishing its quick duet. The final chord will pass through the earth tonight and leave a tiny change in the length of a laser's path. In the near horizon hush of another system, quantum texture may or may not be throwing back a faint echo that we will learn to hear. And beneath all of it, the old possibility persists, that the surface of things remembers, that the outside already holds the inside story, that when we learn the language of these waves, we will be reading history written on a skin. Let that be the mood you drift with. Instruments becoming more attentive, the dark no longer mute, the notes growing long enough to show their grain. Whether the border is smooth or softly structured, whether some holes are actually bridges, whether echoes are rumor or record, the listening itself is a kind of knowing. The universe is speaking at last in a register we can receive, and in its low, steady vowels are the contours of horizons, the possibility of tunnels, and the quiet promise that even the deepest mysteries prefer to whisper their answers rather than shout. Without leaving the pillow, the mind can wander inward toward a dark circle where gravity gathers every path. The reputation of such places is severe, and rightly so. Some black holes are small enough that the pull changes brutally across the length of a body. Tides there would thin anything into a thread long before reaching the rim. Astronomers gave that fate a playful name, spaghettification, but nothing about it is playful. It's quick, violent, and final. Scale changes the script. Far larger holes, those slow hearts at galactic centers, spread their gravity more gently near the border. The difference in pull between head and heel is mild at the horizon of a supermassive giant. Crossing that boundary could be indistinguishable from ordinary drifting. No jolt, no line on the sky, just one more breath carried a little farther in. The quiet itself carries a different kind of dread. After that step, no word returns outward, no pulse of light, no radio murmur. Any last message would need to be sent moments before the crossing. Beyond it, you are present only to the inside. From a distance, the approach looks almost serene. Acceleration begins as a suggestion, then grows insistent. Around the silhouette, a ring of fire, gas, and dust heated by their doomed spirals throws a halo. Behind the dark center, the field of stars warps and pours into arcs. Gravity bends their light into patterns the day world never shows. The black circle is not a hole in a surface. It is a region where every outward road curves inward more strongly than light can outrun. Time plays two roles in this scene. For the traveler, seconds behave like seconds. A clock on a wrist moves with the same metronome it always has. A watcher far away would read a very different tempo. The traveling image slows, reddens, fades, and seems to pause right at the rim. From the traveler's side, the outside ages in a rush. Colors slide toward deeper red and then beyond sight. Distant histories speed by in a hush, as if an entire future were being turned through rapidly. Nothing in the crossing announces itself. The horizon is only a boundary in the bookkeeping of paths, not a surface or wall. One moment counts as outside, the next as in, and the body notes nothing new. What comes later depends on how the inner story is written. Classical equations funnel all roads toward a point of impossible density, a singularity where the math goes voiceless and every attempt at escape is identical to trying to reverse time itself. That ending may not be the last word. Quantum rules those that choreograph the very small hint at softer cores, structures that blur the crushing point into something extended. A journey might continue through regions where distance loses its common sense, where direction feels like a thought more than a line. Destruction could still be waiting, only not as a single blow, but as a drawn-out, unweaving, ornamented by wonders. Another oddity emerges near this border. From the falling person's view, the outside universe may race ahead. Minutes inside could correspond to ages outside. Galaxies drift farther apart. Long-lived stars coast into red. New ones flare and cool. And whatever stories intelligence writes might arise and fade, all while the traveler counts a small handful of breaths. It is not a magic trick. It is the geometry of time under strain. The tale of survival often turns toward a different kind of ingredient, negative energy. The phrase sounds mischievous, but in the arithmetic of quantum fields, it appears in special arrangements. Energy that subtracts rather than adds. Gravity near a black hole bends routes toward the center. A bath of negative energy would act like a local cushion, easing the gradient, softening the stretch. Wrapped in such a field, a body would feel less pull, less thinning, perhaps a sense that gravity has been muffled. Materials capable of carrying negative energy are called exotic for good reason. They are not atoms and molecules behaving as usual, but arrangements where pressure and energy density take on signs opposite to everyday matter. A small, real-world hint exists in the Casimir effect. Two metallic plates held astonishingly close in a vacuum experience a tiny inward urge because the quantum jitter between them is reduced compared to the outside. Mathematically, that gap behaves like a patch of negative energy. It is delicate and local, visible only to instruments that can weigh the lightest whispers of force. No engine can be built from it. No capsule could be lined with it. Still, it proves the vacuum's restlessness can be shaped. Dreams of passage lean on that same strangeness. Wormholes and warp bubbles, the gentler words for shortcuts and rearranged roads, would need sustained negative energy to hold a throat open or to curve a pocket of space into a safer route. Equations are willing in principle, but the bill is immense. Quantities far beyond anything the Casimir setup suggests, and stability that quantum fluctuations would try to spoil at once. Nature seems to guard these doors with moving hinges. Even so, thought experiments keep some daylight between impossible and not yet. Violent places in the universe may host brief pockets of the right sort of energy. Near horizons, in particle storms, wherever fields churn, there could be fleeting deficits that nudge geometry for a heartbeat. They would not save a ship, but they might shade the way a horizon radiates, or how a near-horizon vibration fades. Those are subtle effects, best pursued with patience and long listening, not with blueprints. Return to the traveler, now well inside. The sky behind has dwindled into a dim memory. Ahead, darkness thickens into a texture more than a color. The body is still whole if the black hole is enormous. The tides are patient here. Motion inward is not a choice, but a property of time in this region. Clocks still tick, but their meaning has joined the flow. Some calculations based on rotating black holes admit routes that curve back on themselves in time, or regions where space and time trade jobs. These are mathematical rooms, not promises. Their furniture may topple when realistic turbulence, quantum grain, and infalling matter are added. Yet their presence in the equations expands imagination in a measured way. The interior might be more than a straight plunge. There is grace in admitting the limits of what can be known and keeping the story true to what the sky allows. A small black hole is a place of immediate tides and abrupt ends. A supermassive one can host long, quiet descents and views no eye has held before. Signals end at the horizon. No experiment crosses it and returns. Negative energy exists in tiny, fussy pockets and gives us metaphors, not machines. Exotic tunnels and warped corridors demand ingredients beyond our pantry and seem eager to collapse if assembled. Even within those boundaries, the account remains tender. A person falling toward a gentle giant could witness the far-off universe hurry through its chapters while inside time keeps an ordinary beat. Light would smear into rings and arcs as starlight bends. Colors would deepen, then dim. The crossing would pass without ceremony. Deeper in, the geometry would lift out of the ordinary, and in that strangeness, awe would sit next to dread like two readers sharing the same quiet page. The ideas that promise, rescue, or travel cocoons of negative energy, sculpted tunnels, function best here as images that teach. They show how gravity is not merely a pull, but a shape the world takes, and how quantum rules can push back in surprising ways on very small scales. They remind us that empty space isn't empty, that horizons are not surfaces, and that endings in physics often masquerade as invitations to think more carefully. Breathe with that. Somewhere, near a galactic heart, a dark circle is surrounded by a halo that swirls and flares, writing slow calligraphy in hot gas. Somewhere else, two plates in a laboratory tugged together by less than a whisper, proving that the vacuum has texture. Between those scenes lies the quiet truth carried through these hours. Terror and beauty share a border inside a black hole. The road in can be smooth, the view astonishing, the end uncertain in its details. And the universe, even at its most extreme, keeps offering new ways to be understood, ways that arrive softly enough to fall asleep to, even as they trace the edges of the unknown. Far ahead on the timeline, picture a culture so seasoned by curiosity that it treats space-time as a craft and quantum fields as thread. Mastery of negative energy would sit in its toolkit the way a compass sits in ours. With that strange resource, protective shells could hush the sharpest tides near a horizon. Hulls would glide where ours would tear. Crossing the rim would feel like slipping beneath warm water. Tidal strain softened, instruments calm, crew unhurried. Inside the dark, such control becomes more than armor. It becomes guidance. Space-time, near a hole, is not a straight hallway, but a braided maze. A tuned pocket of negative energy could act like a trim tab on an ocean liner, biasing trajectories by inches that grow into miles. Course changes, once impossible, inch the craft toward quiet eddies, a long-lived throat, perhaps even the mouth of a tunnel that opens somewhere else. In this choreography, falling need not be surrender. It could be navigation. These are visions for a distant century. No laboratory has bottled negative energy on demand. No engineer has coaxed a steady shield from the jitter of the vacuum. The same laws that admit the effect in tiny, flickering patches may forbid it at scale. Even so, ideas like this do real work. They force the mathematics to confess where it is supple and where it is stern. They remind us the vacuum is not a blank page, but a page already written on in faint ink. Turn the page to string theory, where the basic actors stop being points and become filaments, each a loop of energy, so small that an atom scaled to a solar system would still make a string look like dust. What a string plays decides which particle we meet. One vibration hums as a photon, another as an electron, another as a quark. Nature's catalog becomes a score, and matter is the music. In that score, a black hole's heart changes character. The traditional singularity and infinitely sharp note no longer fits. Strings stretch before they crush, smear before they spike. The interior can be reimagined as a dense, stormy tangle of filaments, a fuzzball. The horizon remains a one-way veil, but beyond it, the smooth pit is replaced by a knotted sea. Gravity stays relentless. What changes is the microstructure that bears it. Strings do not live only in the familiar three directions and a ticking time. Extra dimensions, curled into intricate shapes, give the filaments room to move and tie. Mathematics gives those shapes names Calabi-Yau among them, and the whole ensemble can grow into higher dimensional sheets and volumes called brains. Some versions even set our entire cosmos on such a brain, a floating sheet in a larger room. In that setting, a fall toward a black hole is not only a plunge in space, it is an encounter with geometry folded beyond ordinary intuition. A subtle beauty ties the inside to the edge. When physicists count the possible ways a black hole can be arranged at the microscopic level, the tally scales with surface area, not with volume. Information seems to prefer the skin. This is the holographic whisper. A boundary can encode a whole interior. In more technical language, a curved world with gravity can have a mirror description without gravity on its edge. The bulk and its border tell the same story in two dialects. From the storytelling view, whatever the strings do within is faithfully written on the horizon's ledger. From here, the singularity begins to look like a mirage, caused by treating space-time as perfectly smooth. Zoom down to the string scale, and the smoothness dissolves into texture, like fabric under a microscope. A supposed point becomes a knot of motion. What looked like an end turns into a failure of approximation. Even Hawking's whisper radiation from the rim acquires a new flavor. Not only pairs from the vacuum, but the restless song of strings themselves. A leak of melody as filaments tug and reconfigure right at the threshold. Another route to the heart leaves strings aside and rebuilds gravity itself grain by grain. Loop quantum gravity proposes that space is woven from tiny loops, a web so fine that everyday distances seem continuous, yet granular underneath. Press too hard, and the weave resists, the way coils in a spring stiffen when crowded. In this view, collapse inside a black hole reaches a smallest size and rebounds. The interior history becomes compression, pause, expansion, a bounce. That rebound carries a remarkable consequence. The space within a black hole can blossom into a fresh, autonomous expanse. Not a tunnel back to here, but a new there, with its own distances and time. The mathematics does not need exotic matter to achieve it. The bounce emerges from quantizing the same geometry that general relativity bends. Where Einstein's continuum predicts a breakdown, the loop picture inserts a safety rail made of discreteness. Notice how the two visions diverge while aiming at the same sore spot. Fuzzballs replace the interior with a dense surface, everything stored near the horizon, nothing hidden deeper in. Loops keep an interior and give it a new ending. No singular spike, but a compressed core that turns outward into a new region. Each story softens the infinities. Each tries to keep information honest. The differences are not a quarrel so much as two sketches of the same mountain from opposite valleys. Experiments are the arbiter, and they arrive quietly. Ring-downs from mergers can be sifted for extra notes that betray a structured border. Horizon silhouettes can be filmed rather than photographed, their edges flickering as matter swirls subtleties that hint at what the surface can store. Gravitational wave echoes, should they stand the scrutiny of better instruments, would argue for texture where a clean horizon was expected. None of these are single trump cards. The truth reveals itself as a pattern that repeats across events. Fold the far speculation back into our central wonder, a universe that might live within a black hole. String pictures emphasize the horizon as a recording surface. Loop pictures emphasize an interior that continues. Both make room for a parent and child relationship between regions of space-time. Both make sense of area counting more than depth. Read this way: a black hole in a larger cosmos could be a seed whose interior grows into a sky like ours, and our own horizons could be skins that quietly keep the record of all that has ever fallen. No need to hurry the conclusion. The late-night comfort comes from the shape of the questions. Can negative energy be steadied into a tool, or does nature keep it fleeting on purpose? Is a black hole's border a smooth veil or a textured archive? Does the interior end in a knot of strings, or in a granular bounce that opens the door to elsewhere? Each possibility leaves a different fingerprint in waves, shadows, and timing, and our instruments are learning to feel at that sensitivity. Somewhere in this weave, the fear of falling softens into a different emotion, one that watches the deep with steady breath. The thought that our entire sky might be an interior does not make the stars less real. It makes reality more layered. Horizons, then, are not merely endings, they are pages. And the pages, though dark to sight, are written on in ways that listening minds can slowly learn to read. Earlier we held two sketches side by side, fuzzball on one page, bounce on the other, and a single thread separated them: time. In the fuzzball portrait, the story pauses at the surface. There is no after, only a richly textured border that keeps the record. In the loop gravity bounce, the story continues. Collapse tightens, reaches a smallest scale, and then unfurls again as a new beginning. The film doesn't end, the reel switches theaters. That difference reshapes the old puzzle about memory. Hawking taught us to expect a thin, patient glow from every horizon, and at first glance, that glow looked forgetful. In a fuzzball world, the ledger sits on the skin. The glow becomes a slow transcription of what the skin stores. In a bounce world, the script is conserved in a different way. The lines pass through the narrowest moment and are performed in a room we can never enter. Information isn't burned, it's relocated, kept safe behind a curtain that never lifts for us. Follow that thread, and a bolder thought arrives quietly. Our own sky could be the inside of such a continuation. The background afterglow that washes the night, the microwave hush from when the cosmos was young, might hold tiny scars of an earlier collapse, faint rings or alignments in its grain. Nothing decisive has surfaced, but the search itself is a kindness. It gives the question a place to sit while we listen longer. The bounce reframes a black hole's old age as well. Classical pictures lean on a slow fade, eons of Hawking whisper, and then emptiness. With quantum grains of geometry in play, the finale could be brisk, a swift change when the object shrinks to the smallest scale. To an outside watcher, the dark spot may simply vanish in a brief sigh of energy, while inside a spacious region ignites, beginning its own arithmetic of distances and time. Two views of one hinge. Some equations even hint at delicate correspondences between the two sides, not corridors to stroll, but relations that keep books balanced across worlds. Entanglement becomes accountancy. No signal crosses, yet the sums agree. Ideas like these are not daydreams. They are disciplined invitations to refine mathematics, to build instruments, to ask better questions of the sky. Step now into the pocket where time itself feels different. Near any horizon, the clock you carry refuses to match clocks far away. From within, seconds behave normally. Glance outward, in thought, and the wider universe appears to sprint. Whole epochs can flicker past while your own heartbeat keeps its pace. Some physicists arrange this into a static tableau, the block universe view, where past, present, and future form a single sculpture. Inside a black hole, that sculpture feels almost literal. The geometry channels every traveler toward a particular slice of the future with the inevitability of a moving walkway. That image tugs at free will, as persistent as a tide. Quantum rules muddle the neatness. At small scales, histories cohabit. Outcomes remain unsettled until interactions press them into a choice. A full union of gravity with this probabilistic grammar might soften the starkness of a fixed end, blur the singular point into a textured region, or route evolution through alternatives we barely have language for. Until that union stands, the center remains a quiet marker, approached by many paths, explained by none completely. There is a more buoyant counter-image too, a black hole paired with its time-reversed twin, where one swallows, the other expels. Link them, and endings become openings. Collapse curls into expansion. A chain of rooms could result regions feeding regions, each entrance someone else's exit. The word white hole is awkward and old-fashioned, yet the intuition it carries keeps returning. Flows can reverse on the far side of a horizon. Now, bring the lens close to home. Suppose the room we occupy is an interior. Nothing dramatic would announce that fact. Horizons in such a setting live too far out to visit. The curvature is so spread that local space feels ordinary. Think of standing inside an enormous sphere with walls beyond any reach. From where you stand, the floor looks flat. Expansion wouldn't be escape into a surrounding place. Space itself would be lengthening. Galaxies would drift as distances grow, and yet an unreachable boundary would still outline the whole, not outside us, but enclosing all viewpoints at once. Paradoxically, life inside a very large black hole would feel gentle for a long while. Tides scale with size. The bigger the object, the softer the pull across a human frame near its rim. The universe we measure has that same soft hand on large scales. Calm geometry, patient drift, so nothing about daily experience would betray the deeper shape. Some mathematical maps even show that the interior of certain black hole solutions mirrors the equations we use for an expanding cosmos. That echo could explain the sky's evenness and the absence of any clean signature of before. In such stories, small rooms give birth to large ones. A baby universe can grow from a compressed core, inflate rapidly, and pinch its umbilical passage shut, becoming an independent address in the book of space-time. Success requires speed. Expansion must outpace any tendency to fall back. Ours may be one that made it, already unhooked from whatever parent collapsed to begin the process. The idea won't sit still. Eyes return to the present sky and wonder whether this branching goes on, incessantly new rooms budding in the dark hearts we chart by their gravity. It is easy to picture a forest of worlds, each with its own chemistry of stars and questions, each peopled perhaps by minds that stare upward and form the same suspicion we're nursing now. A quieter quantum twist waits near every border. In ordinary life, barriers reflect. A tossed ball returns. At small scales, barriers sometimes relent. A particle can appear on the far side without taking the path in between. The wall becomes permeable in a statistical, haunted way. That behavior tunneling is the same style of mischief that nourishes Hawking's whisper. Near a horizon, the vacuum is lively. What counts as inside and outside depends on who's asking and how quickly the question is posed. At that seam, rare exchanges can occur. Correlations thread across, pairs split, with one partner freed, and the boundary behaves less like a welded seal and more like a membrane with rules. That doesn't turn a black hole into a revolving door. Signals do not stroll out carrying messages, and nothing macroscopic unfalls. The meaning is subtler and somehow more satisfying. Even the most forbidding edges in nature participate in the quantum give and take that keeps accounting honest. The world does not contradict itself. It keeps a careful balance, line by delicate line. Fold all of this back into the question that has been breathing beneath our narration. What changes about our belonging if the whole sky is inside? Strangely, very little, and also everything. Galaxies remain as they are. The moon still lifts the tide. The rhythm of breath still sets the meter of thought. Yet horizons acquire a second life in the mind. Not only distant limits of sight, but pages where stories are stored, hinges where beginnings disguise themselves as ends. Fuzzballs teach us to respect the surface. Bounces teach us to respect continuation. Both insist on memory. Some night soon, new instruments will parse the fading tones of a merger and weigh the texture of a border. Maps of the ancient afterglow will sharpen and either reveal small circles of oddity or set tighter bounds on how smooth the first light truly was. Equations will learn to sing together instead of in parts. Until then, there is time to rest with the outline. Our universe may be a room grown from a deeper gravity. Its horizon may be writing as we speak. Its future may already exist in the way a road exists over a hill, hidden but paved. None of this needs to jar the nerves. The drift of thought can remain slow, like a leaf on dark water. Somewhere far away, something collapses and becomes a seed. Somewhere nearer, a laboratory weighs the tiniest deficit in the vacuum and confirms that emptiness has texture. And here, between those scales, a listener in a quiet room considers the possibility that home has always been an interior and finds the thought less frightening than expected, more like a lullaby written in the margins of space and time, continuing beyond the frame, steady as breath. Closer in, another picture forms, less a single room, more a stack of rooms. Some physicists sketch the interior as layered like an onion, each stratum a distinct quantum state with its own density, its own way of bending distance and ticking time. To classical intuition, those layers are unreachable, sealed behind gravity's tight handwriting. At quantum scales, though, barriers behave differently. Waves seep paths forbidden on paper acquire a thin, silvered chance. Through that seepage, not only particles but bits of information can slip between strata, turning the inside into a quiet labyrinth of zones, some steady, some flickering, no two quite the same, all hidden from exterior sight. Everyday barriers are walls you can touch. The quantum kind are rules against entry, and rules unlike brick admit loopholes. Where a particle would bounce in ordinary life, a wave can borrow a narrow corridor through the forbidden, reappearing on the far side with its story intact. Deep within strong gravity, the stakes rise. Geometry knots up, corridors close, routes curve into themselves. Tunneling sketches new alleys through that tangle, sideways passages that ordinary falling cannot reach. A traveler's classical line might end at the central crush, yet the quantum map keeps extra doors brief, improbable, but real enough to matter over the longest breaths of time. That viewpoint turns a black hole's core from a one-way chute into a hush of hidden interiors. Energy pools behind veils. Information folds into ripples of geometry. In the corners, pockets might hold the seeds of larger spaces. String theory and loop gravity both hint at this restlessness. In those frameworks, space-time itself is lumpy filaments, loops, and tiny bubbles, forever jittering. In such a foamy medium, tunneling is not an exception, but part of the grammar. The interior becomes weather, eddies of space, gusts of time, a storm of overlapping microworlds, where memory can persist in patterns we have not yet learned to read. The old paradox about lost information softens here. Instead of being erased, the record can migrate, shuffled across layers, encoded in the foam, preserved where no telescope can peer. The simple tale of a smooth plunge gives way to something more intricate, a quiet wandering through a maze whose walls rearrange without a sound. From that maze, another audacious line of thought rises. New rooms can bud from the old. Classical collapse points toward a singular halt. Quantum rules often replace halts with detours. At extreme compression, a region may tunnel into fresh space-time and then swell an inflationary bloom cut off from its parent. A baby universe starts as a whisper and grows into its own sky. The mirror question hangs in the air like a mobile. Could our sky have begun as such a detour, launched from a collapse elsewhere, now long since unhooked and sailing on? A subtler twist waits in how we count reality. In quantum mechanics, what exists is braided with who looks and how. Before measurement, a system lives as a cloud of possibilities. Observation presses that cloud into a single scene. Extend that logic to a black hole's depths, and the interior stops being a fixed cavern and starts behaving like a stage, assembled as the play begins. The very presence of an observer, no force, only attention selects a version of the room. Complementarity prepares us for this. Distinct observers may carry away descriptions that cannot be stitched into one picture, yet none of them lies. The interior then is not a single map rolled up and waiting. It is a living process, a tapestry woven from relations among fields, matter, and any witness who crosses the veil. Relational interpretations carry the thought further. Quantities like position, energy, and momentum are not properties that float alone. They are agreements between systems. Space-time itself can be seen as the sum of these agreements, a fabric of entanglement rather than a stage beneath it. In soft night words, the room is made of relationships. Two outwardly identical black holes, same mass, same spin, might still host different interior stories because different travelers, following different threads of interaction, help stitch different tapestries as they fall. Not fantasy, but a quiet recentering of what exists means at the edge of certainty. That fluidity includes time. Outside, a black hole's outline can look frozen, an eternal statue of night. Inside, the flow continues, though it may curve around corners and double back through eddies. Sequences need not be universal. Order can depend on which measurements get made and in what rhythm. The unsettling questions arrive without raising their voices. Is there an interior before anyone observes it? Does the act of witnessing guide the river's course? On cosmic scales, could the whole universe be participating in this mutual shaping, each new look a loom throw that strengthens the fabric? Step beyond our walls, at least in thought, and the canvas widens. A parent cosmos could have birthed ours through the collapse of some massive body to a horizon on the other side. From outside, that object would be unremarkable, dark, and patient, leaking hawking warmth so slowly it might as well be silence. Inside, a complete history could be unfolding, galaxies coalescing, stars igniting, minds learning to name constellations. Rates of time may bear no resemblance across the two addresses. A blink there, billions of years here, or the reverse. The book remains open on both tables, but the page numbers no longer match. Traits could pass down that family line. The spin of the parent's black hole might bias the child's large-scale rotation. The mass could set an initial energy scale. The charge might leave subtle asymmetries that only the most delicate surveys could one day notice. Each universe inherits a few habits, yet grows into its own posture, the way a tree echoes its seed, but spreads branches according to wind and light. Other possibilities paint the parent as utterly alien, different mixtures of fields, different ease of forming stars, different thresholds for gravity's collapse. To dwell inside one cosmos is to find its laws natural. To visit another, in imagination only, is to realize how rare our normal might be. The same humility returns again and again. What feels obvious here could be a narrow island in the archipelago of what's allowed. Amid these wide turns, the physics keeps its quiet discipline. Tunneling through horizons is not a freeway for signals, only a whispering mechanism for correlations and rare quanta. Hidden interiors do not rescue travelers, they rescue consistency. Observer-shaped rooms do not hand reality to whim. They remind us that measurement and meaning arrive as a pair. Baby universes do not prove themselves with one spectacular event. They would reveal their plausibility through patterns, slight signatures in the ancient afterglow, repeated quirks in gravitational wavetails, persistent hints that areas not volumes count the ways inside can be arranged. Set the book down by the bedside for a breath. The thought that our universe might be an interior among interiors no longer feels like a cliff, more like a shore where two waters meet. Beneath the starlight, layers could be stacked, doors could open only in probability, time could slide in curves, and reality could answer to relation more than to absolutes. None of that breaks the softness of tonight. It deepens it. Somewhere beyond our reach, a parent sky may still be turning its seasons. Somewhere within our reach, instruments are learning to hear the faintest overtones of horizons. And here, where breathing slows and the room grows gentler, the mind can hold both truths at once. The world is steadier than fear suggests and stranger than habit allows. From here, the view widens gently. A single universe can feel singular and complete. Yet the story we've been tracing leaves room for ancestry. A parent cosmos rich in stars would have birthed countless black holes. Each collapse could have seeded a self-contained world with its own distances, its own clock. Ours may be one child among uncounted siblings, a quiet leaf on a branching family tree. Perhaps that parent's sky still turns, strange and immense. Perhaps it faded long ago, leaving only descendants drifting through their private time, fossils of a greater event, warm with their own histories. Our night carries the same potential. The dark cores we map could be nurseries, their interiors swelling into separate rooms of reality. In such a genealogy, infinite would describe not a single boundless space, but a cascade of space-times, related yet apart. An outside to our universe would not be empty. It would be someone else's inside, another sky, another ledger of stars, and that one might be enclosed by a larger story still. Whether this nesting ends in a final container or carries on without summit or floor is a question that may forever sit just beyond reach. Reach, nevertheless, can be subtle. We cannot step outside, but the world offers hints at its edges. The pressure that speeds our expansion, dark energy, could be more than an internal quirk. Some have wondered whether it's the faint touch of a boundary, a trace of what lies beyond pressing softly on our side. Mathematics gives such ideas a language. Observations decide which words endure. The oldest light is where we listen hardest. The cosmic microwave background, ancient radio fog from when the universe was young, looks mostly as expected, even nearly featureless, like cool breath across the sky. Hidden in that calm are peculiarities that have refused to vanish under scrutiny. A broad patch in the southern sky runs cooler than its surroundings. The cold spot and large-scale ripples show a curious tendency to align, a pattern playfully dubbed the axis of evil. Early on, many blamed instruments or foreground dust. Years of cross-checks and newer maps kept the anomalies alive. They remain whispers, not verdicts, but whispers that don't quiet easily. Geometry is an artist that leaves fingerprints. A universe born inside curved space would paint its microwave afterglow in ways slightly off from flat expectation. Light in such a room can bend, linger, even loop. Certain topologies closed like a hypersphere or wrapped like a three-dimensional torus could imprint repeating motifs or damp the largest waves. Suppressed power on wide angles, like a hush in the deepest bass, would fit a cosmos with gentle, positive curvature, the kind of closure one might find within a vast interior. The cold spot itself could be a scar from an enormous void along our line of sight, draining energy from passing photons. Or it could be a deeper birthmark of the space we inhabit, a remnant of how our patch first opened. A preferred direction might carry an older memory. If our origin traces back to a rotating collapse, that angular momentum could have left a faint arrow on the sky, the way a potter's spin leaves a subtle line in clay. The broad alignments in the microwave pattern could be that line, stretched thin by expansion but not erased. Polarization, how those ancient waves are oriented, adds more texture to the puzzle. Maps from satellites and ground telescopes show twists and swirls that mostly agree with simple models, yet leave room for nuance, as if the canvas had a weave we haven't fully resolved. Boundaries invite a softer kind of lensing. A finite universe needn't end. Like the surface of a sphere, it can be closed without an edge you can point to. Still, a built-in limit, the sort an interior inevitably carries, could bend the earliest light in subtle rings, smooth certain ripples, amplify others. Patterns that delicate ask for new instruments, and long patience. Teams preparing the Simons Observatory, CMBS-4, and future space missions are tuning their eyes for exactly this: slight circles, small asymmetries, gentle biases in the oldest glow that would betray curvature, topology, or the whisper of a horizon, not of matter, but of meaning. The microwave sky is a treasure and a labyrinth, signals braid with noise. Every answer hides a new riddle, yet the oddities persist, and persistence is its own form of guidance. If our world is an interior, the proof may be nothing dramatic, no revelation at noon, but a pattern of small consistencies across many maps and many years, like tide marks that only make sense when you've watched the shore a long while. Another thread runs through the constants themselves. Our physics leans on plain numbers: the speed of light, the strengths of forces, the masses of simple particles. We measure them, we do not derive them. Nudge them a little, and stars might never light, or atoms might never hold. Fine-tuning has the shape of a question. One answer sketches a garden of universes, where each black hole re-rolls the settings. Most combinations fail. Gravity too strong, and everything collapses early. Gravity too weak, and nothing gathers. Chemistry that never stabilizes. Structures that never grow. Here and there, a rare blend allows complexity, time enough for memory, maybe even life. In that view, cosmological natural selection, black holes serve as the reproductive organs of reality. Traits that favor more black holes echo down the line, not by preference, but by survival. Our cosmos then sits where it does in parameter space, for the simplest reason: skies like ours make many seeds. The thought lands with a kind of quiet mercy. Uniqueness shifts from a crown to a circumstance. Meaning shifts from being chosen to being capable. We remain local and precious, not because we are the only song, but because we are a song that lasted long enough to learn its melody. Where does this leave us? Here in the small hours, with a horizon that might be a page, with constants that might be heirlooms, with light that carries faint letters from before there were eyes to see it. We cannot walk outside our sky. We can listen to how it hums. We cannot rewind its first moments. We can read the way they echo in the oldest glow. We cannot settle tonight whether our world is an interior among interiors. We can notice that the possibility softens dread and deepens wonder at once.